Headlines broke a few years ago about a smallish object traveling through space and behaving really, really strangely. This thing reflected light in a way that suggested it might be sliver or even saucer shaped. And unlike other objects in our solar system, it was definitively not on any kind of orbit around the sun. So was it somehow self-propelled? The mysterious object was given an evocative name, Oumuamua, which is Hawaiian for first distant messenger. And it made sense to ask whether this could be it, the first salvo from an intelligent civilization elsewhere in the universe. From KERA in Dallas, this is Think. I'm Chris Boyd. The thing is, there's a big difference between raising questions that invite further study and reaching a definitive conclusion based on a single data point that vanished from view soon after it appeared. And the story of Oumuamua is both a thrilling opportunity for scientific conjecture and a cautionary tale. Matthew Bothwell is public astronomer at the Institute of Astronomy at the University of Cambridge and author of The Invisible Universe, Why There's More to Reality Than Meets the Eye. His recent article about how we talk about interstellar objects and what they might be is called Contact, and it was published on Eon. Matt, welcome to Think.
Hi, good afternoon. Thanks for having me on.
How did astronomers first become aware of this object that would be named Oumuamua?
Well, astronomers are scanning the skies all the time. It's kind of what we do. And in 2017, this survey called Pan-STARRS noticed that there was a tiny little speck heading through our solar system at speeds that are much, much faster than you might expect for a normal asteroid or comet. It was traveling at nearly 200,000 miles an hour, which is very fast indeed. The excitement really came when we started to track its orbit. So we looked at this thing for several nights in a row and then tried to, kind of extrapolate forward to track this orbit around the sun. And it very quickly became clear that this thing was not gravitationally bound to our sun. It wasn't part of our solar system in any real sense. And the only explanation had to be that this thing was interstellar. It was a piece of a distant solar system that had traveled this unimaginable gulf between the stars and was doing a flyby of our sun before heading out into the interstellar void again.
So it was headed out into the void, meaning we weren't able to look at it for very long before it was not detectable.
Absolutely. We glimpsed this thing for the first time when it had actually already slingshotted around the sun and was heading out of the solar system. So we really only got the briefest look at this thing before it heads out into the solar system and beyond, because, of course, the further away this thing gets, the fainter it gets. These things, comets and asteroids, don't create their own light. The only way to see them is through the light that reflects from the sun. So the further away from the sun that it gets, the fainter it gets. And so this thing is really just heading off into the outer darkness. So we're really not going to be able to we're not going to be able to see this thing again. Basically, this very brief glimpse is all we're ever going to get.
What made the shape of this particular object worthy of so much attention?
Right. So first of all, for listeners, the shape of this object that's interesting is that it's very, very long and thin. Most asteroids and comets in our solar system look roughly kind of like knobbly, dumpy potatoes. They are not quite spherical because they're not big enough for gravity to pull them into perfect spheres, but they're pretty close to spherical. I think, potato shaped is a pretty good explanation. Oumuamua seems to be very, very different. We spotted this, first of all, when we analyzed the light that was reflecting from Oumuamua. Normally from an asteroid, you'd expect it to get maybe 20 or 30% brighter as it spins around. As you can imagine, when the big face is pointing towards you, you get the most light reflected, so it looks brighter. When we did that experiment with Oumuamua, it was getting more than 10 times brighter as it faced us. So the big face was obviously much, much, much bigger than the small face. So it wasn't a kind of dumpy potato shape. It was something very, very long and thin, like a needle or a sausage or something, which was very, very surprising. We'd never seen anything like it in our solar system.
Any idea why it might be that shape?
Well, that's the $1 million question, right? There have been many, many theories, which I'm sure we will get onto over the course of the show. It was definitely tantalizing because this was the first ever interstellar visitor we ever found. And then not only was it the first thing we've ever seen from outside of our solar system, it was also deeply weird. So astronomers have been working overdrive over the last few years to come up with explanations. And the problem, I think, at this point is that we have too many explanations. It's always when you have more explanations than things that need to be explained, it's always an interesting situation to be in. Astronomers, for the most part, have converged on this idea of Oumuamua being probably a chunk of frozen hydrogen kind of chipped off a distant solar system's version of Pluto. So we think it's most likely kind of like a flat dish-shaped thing. So maybe a distant solar system's equivalent of Pluto was involved in some kind of cosmic collision and smashed to bits, and then Oumuamua is a little chunk that got chipped off the surface of a distant frozen world, and so we're essentially seeing a flying chip of ice. That's our best guess, I think.
So I feel sort of dumb about this, Matt, but I hadn't realized before I read your article that all the other things we've cataloged within the solar system are believed to be full-time residents, which is to say they're all locked in permanent orbit around the sun. Does that mean there aren't other objects like Oumuamua out there, or just that we haven't been able to spot any?
It's the latter. It's that we haven't been able to spot them. Things in our solar system that are bound to our sun are obviously much, much more common than interstellar visitors. I think people that, unless they've read a lot of astronomy, often don't realize how ridiculously huge the gulfs between the stars are. Individual solar systems really are these tiny little islands of light and matter separated by, many, many hundreds of billions of kilometers of empty space. But nevertheless, we do think these interstellar visitors are here. I think one of the arguments for Oumuamua being something probably natural rather than something artificial is that we think probably at any given time there are likely to be thousands of these things in our solar system. The problem is they're very, very, very hard to find. It's sort of like trying to find a needle in a haystack if your needle is made of hay, It's a tiny little speck amongst many, many, many other tiny little specks, which makes them very hard to find.
All right, I'm with you so far, but Oumuamua also did one even more bizarre thing, which is that it seems to have picked up speed as it went. Tell us about that.
Right, so that was what's really, I was going to say that's what got everyone's attention. I think the fact that it was an interstellar traveler really got everyone's attention in the first place. But you're exactly right. We became fascinated by this thing as soon as we realized how special it was. And so many of the world's telescopes were tracking this thing very carefully as it moved through our solar system. And we noticed that it was speeding up. It was a very, very subtle effect. It wasn't kind of blasting off to the stars with a rocket engine or something, but the speed was increasing in a way that you normally wouldn't expect, right? If it was just an inert lump of rock, you'd expect it to just go flying through space and not really change its speed. So as you can imagine, people came up with lots of explanations for this. It sounds kind of bizarre. It's not quite as strange as it sounds, because things in our solar system often speed up and slow down naturally by a process called outgassing. So a lot of comets and asteroids in our own solar system often have frozen material, like frozen gas, below the surface. And when they get close to the sun, the gas boils and spurts out like a geyser, right, like a rocket engine, and can move these things around. So we do see this happening in our own solar system. It's not completely unheard of, but it was definitely a surprise to see our interstellar visitor doing this. We didn't expect it at all.
So outgassing is one possibility. Some people got excited by the possibility that this thing might have been built by something other than a naturally occurring thing traveling through space, built by another species and sent here. Before we talk about that, I want to step back for a second and ask you to talk about the ways that we have conceived of intelligent species throughout human history and how those forms reflect where we are at the moment.
Right. So I think anyone that's a sci-fi fan will have come across depictions of extraterrestrial life, right? I mean, people have been thinking about extraterrestrial life for a very, very long time. I think the ancient Greeks before Socrates, they wouldn't have put it in these words, right? They wouldn't have talked about aliens on other planets, but they did wonder about other beings in other worlds. So people have been thinking about this for a very long time. I think what always strikes me when I read and hear depictions of what extraterrestrials might be like, I feel like we always bring a part of ourselves to the discussion. Human beings we are human, right? We're not these pure beings of reason. And I think we have these preconceived ideas of what things might be like. And I think we often bring those things to the table when we think about aliens. So just for some examples, right, I always find it really interesting that in the 19th century, Victorians, in England at least, it was very widespread, the idea that there were people and living beings on Mars. And the general idea was that these beings on Mars were engineers involved in these kind of grand planet-spanning engineering projects. The famous things we're looking at canals, things that we now know are kind of dried up rivers on Mars's surface. They thought they were artificial canals. And I think it's really telling that people looked at Mars and saw these globe-spanning engineering projects in the exact period of human history when we were embarking on big globe-spanning engineering projects like digging the Panama Canal and all stuff like that. If you jump forward to the 1960s, during the Cold War, this theory took off called neo-catastrophism, this idea that the reason we seem to be alone in the universe is that extraterrestrial civilizations tend to nuke themselves out of existence. I think it's really telling that became popular in the 1960s when the Cold War was very much on everyone's minds.
Yeah, it is interesting that we sort of vacillate, right, between imagining intelligent life as being a potentially benevolent protector and imagining it as like a ruthless colonizer or a wanton destroyer.
Yeah, absolutely. And I think it literally depends who you ask. I feel like it's maybe one of those kind of glass half full, glass half empty personality tests. Do you think that aliens are going to come and want to murder us all, or do you think they're going to come and, solve all of our problems?
Do you will you share which camp you're in if you're in either camp?
I think I might be. I feel like I might be in the glass half full friendly alien camp. This is saying more about me than what aliens are really like. I like to imagine that if aliens are smart enough to solve their own technological problems, they will have maybe transcended beyond the petty squabbles and the problems that we are experiencing here on Earth.
So Oumuamua shows up. It behaves very strangely. It's speeding up as it leaves the solar system. It is the first object that we've identified that is an interstellar object that has come through the solar system, which is to say, it provided a tantalizing puzzle for astronomers to think about. And people threw around a lot of different ideas, batted those back and forth. Then this Harvard scientist stated pretty definitively that this must have been an alien artifact of some kind. What did Avi Loeb and his co-author Shmuel Bialy think explained Oumuamua's acceleration?
So Avi and Shmuel published this paper in 2018. The title was "Could Solar Radiation Pressure Explain Oumuamua's Peculiar Acceleration?" So the crux is this speeding up that we discussed in the first section, the fact that Oumuamua seems to be being pushed faster and faster as it leaves our solar system. One explanation was the one that we talked about earlier, that they might be outgassing. So some gas under the surface of this thing might be boiling and pushing this thing along like a rocket engine in a way that we see in our solar system. But this new paper suggested that Oumuamua might behave in the way we're seeing if it is not a lump of rock, but is something called a solar sail. So a solar sail is a hypothetical piece of technology which we're not able to build yet, but people have been dreaming about for years and years. The idea is to build a giant sheet out of some reflective material and put it in space, and then that could be pushed along by the pressure of starlight. And as you can imagine, starlight doesn't have much of a push to it, but the push could be exerted over years and years and years, and gradual acceleration over years and years and years can get you very, very fast indeed. And so people have been thinking about building solar sails for a couple of decades now as a way to explore other star systems. Obviously, here on Earth, it's going to wait until we need new technology. But then this paper by Avi Loeb and Shmuel Bialy, this suggested that Oumuamua could be a solar sail. So that was their explanation for this strange acceleration.
So it's very exciting to think about. But here's where you think Loeb and Bialy might have fallen prey to the same kinds of errors that befell the Victorians, right, who assumed Mars was full of canals. What else is going on in Loeb's life?
Well, he's been he's been very passionate about this idea as well as pitching it scientifically. He has written a huge number of popular articles and even a book called Extraterrestrial: The First Sign of Intelligent Life Beyond Earth, where he pitches this idea. He's also works for this project called Breakthrough Starshots, which is one of these projects I spoke about before that is investigating the idea of building solar sails. So I have no doubt that he spent a very, very long time thinking very hard about solar sails. So I do wonder if with those ideas in his mind, if that maybe primed him to see this as a solar sail, because he spent so much time thinking about the possibility of one.
So even the most eminent scientists are not immune to their own biases and their own experiences influencing the way they look at things.
Absolutely. And I think the beauty of science is that no matter how eminent you are, it's possible to be very, very wrong. There's a close to home for me, there's a famous scientific argument about 50 years ago where Fred Hoyle, famous British astronomer, who was kind of the Neil deGrasse Tyson of his day. You know, he was very eminent and great popularizer of science, went on the radio and everything. He was firmly against the Big Bang, right? He spent a lot of his career saying the Big Bang didn't happen. He was about as eminent as it's possible for an astronomer to be, and he was wrong, right? But this is okay. It happens. It's part of the journey of science. Is this kind of critique and sharing of ideas.
You also write here about a controversial figure named Benjamin Zuckerman at UCLA, and his thinking is that if intelligent aliens existed, we would know it by now. How do Zuckerman's ideas correspond to his positions on immigration among humans?
Yeah, so this gets this gets into the weeds a little bit. So Benjamin Zuckerman is this professor at UCLA, and for a very long time he has been opposed to SETI. So SETI is the search for extraterrestrial intelligence, this astronomer's quest for life in the universe. Zuckerman has been as a bit of a SETI skeptic for most of his career. About a couple of decades ago, he wrote this very famous paper called "Why SETI Will Fail," which basically argued that any extraterrestrial intelligence is almost certainly very, very rare. The reason for these arguments are, as you say, kind of tied into some slightly controversial ideas that he has about immigration. The reason that he thinks SETI will fail is that we don't see aliens around us. So he has this model of how extraterrestrial civilization would work, which is basically that civilizations grow up around stars in our galaxy, and then one day, eventually their stars die, and when their stars die, they have to set off for new shores and find other solar systems to live in. So he basically casts extraterrestrials as migrants seeking a home after some tragedy. And then from the fact that our solar system appears to be not colonized by extraterrestrials, he says, well, they probably have to be very, very rare then, because otherwise they will have emigrated here after the destruction of their home system. This is almost a mirror image of his views on immigration. He has been part of this organization called Californians for Population Stabilization, which opposes immigration into the United States on environmental grounds. And I think it's very interesting the way the light in which he casts extraterrestrials is almost identical to the light in which he casts human migrant populations coming into the United States. You can see the patterns of thinking in the same way.
So his idea is that if space travelers were in the neighborhood, it means that they're looking to take over.
Right, exactly, yes. So he has this famous line in one of his papers where he says something like, in a crisis such as one of the death of one's home star, would the fleeing migrants worry about preserving wilderness areas? So he basically he casts our solar system as a pristine area of cosmic wilderness, and imagines that if there were any intelligent things in our neighborhoods, they would have come and plundered us from our taken our resources, and we would no longer be an area of pristine natural beauty or whatever. And so, the fact that the solar system is untouched suggests that we are alone to him.
Matt, you mentioned SETI, who Benjamin Zuckerman thinks is destined to fail. The folks there at the Search for Extraterrestrial Intelligence have been listening for evidence of something intelligent out there for decades. And they're listening for radio signals. Is that right?
That's exactly right. Yeah. So radio signals travel very easily between the stars, and so we think if other civilizations were trying to be heard, there's a very good reason to think that they would be using radio signals to try and transmit their message. So yes, SETI, this search for extraterrestrial intelligence, spends a lot of time pointing radio telescopes upwards and hunting for any intelligent signals from the stars. And so far, they've found nothing. It would be headline news if they found something. So far, it's been radio silence.
I like thinking that someone very far away might be listening in on our conversation regardless. But why radio signals? I mean, as it is, we've only had this technology for a short time. There may come a time when we're not broadcasting things via radio signals. Is this not a kind of limited thing to be looking for, given that we have no clue about the kind of technologies other civilizations might develop?
You are absolutely right. So I think that there is a pretty good reason for using radio signals, but which I'll come on to in a moment. But you are absolutely right. And I think this is the eternal bugbear of this entire type of field, right? That we have to make assumptions and make guesses about what other civilizations might be doing when we have no idea, first of all, if they exist at all. And then secondly, if they do exist, we have no idea about the way they might see the world or how advanced they might be or what they might be prioritizing. It could be that alien civilizations exist and just feel no reason to talk to us or anything, which is why there's silence. So there are a lot of assumptions that go into anything in this field. As for why radio signals, though, so radio signals are a type of electromagnetic wave. So along with optical light that we see with our eyes and infrared and ultraviolet, they're all different types of electromagnetic wave. Radio signals travel very, very easily through space. They don't get blocked by things like clouds of dust and clouds of gas. So optical lights, the light that we see with our eyes, is very easily blocked in long journeys across space. So if you wanted to communicate over very, very long distances, radio waves are the best way that we know of doing it. And so it's an assumption that we make. It's the easiest way that we know of doing it. It doesn't necessarily mean it's the best way or what these civilizations might do. But you have to start with what you know, right?
So the SETI folks have found nothing thus far, but in any case, they believe in the possibility of alien intelligence. What was their take on the discovery of Oumuamua?
So I think they found it interesting, absolutely, but generally the feeling has been skepticism. For several reasons, really. So we spoke at the start about how interesting it was that Oumuamua was speeding up, and that made it tantalizingly artificial. But you might think that if it was an artificial probe sent to our solar system, then it might at least slow down to take a look at us as it flew past. But it didn't. It didn't show any sign of slowing down as it went past. It was also completely radio silent. So we were talking about these radio telescopes listening to the cosmos before. We pointed a lot of radio telescopes at Oumuamua, and it was completely radio silent. I think the other big SETI argument for Oumuamua not being an alien spaceship is really just how small it was. The fact that it didn't slow down and didn't try and say hello suggests that if it's an alien spaceship, probably the best it could be doing is just looking at us as it flies past. But Oumuamua is really comparatively quite small, and you could build a better network of telescopes in a nearby star system and get a much better look at us than anything Oumuamua can do. So for a lot of the SETI folks, there are lots and lots of reasons why we don't think Oumuamua is likely to be artificial. So as exciting as it is, I think the prevailing feeling is definitely one of skepticism.
When you say it's relatively small, how closely can astronomers pinpoint the size of the object itself?
So our best guess is that it's around 100 meters in its shortest dimension. So if you imagine it like a long, thin needle or something, it's maybe a few hundred meters long, but less than 100 meters in its widest dimension.
Did the serendipitous discovery of this particular object teach astronomers anything about the right thing to do to find others? Will it get easier to discover these objects now that we've identified Oumuamua?
So it will definitely get easier in the future. I don't think it will get easier because we found Oumuamua. I think we always knew how to find these things. It was just solving the needle in the haystack problem. The way to get better is to build more powerful and smarter telescopes and more powerful and smarter surveys to study the sky. Which luckily is exactly what we're doing. So we have a new telescope coming online at some point in the next couple of years called the Vera Rubin Observatory, named after Vera Rubin, the pioneering astronomer who found dark matter. The Vera Rubin Observatory is going to do this enormous survey and photograph the entire sky every few days. And it's going to be very, very powerful at finding small things that are moving around in our solar system. It's going to be the best look we've ever got at the tiny bodies that inhabit our cosmic neighborhoods. And I think the Vera Rubin Observatory is likely to find more of these things than ever before. So yes, the good news is it will get easier, but it's based on how good our technology is.
So Avi Loeb made fairly definitive proclamations about what he thought Oumuamua must be and why it was accelerating. He was convinced it was some kind of solar sail. This is just a conjecture, but lots of people in the scientific community disagreed. What was noteworthy about the way Loeb responded to his critics?
So I think, and I think this gets to the heart of the disagreement between Loeb and the rest of the scientific community. It wasn't so much that he floated these ideas, because they're very interesting. And as we were saying before, the speculation is the creative driving force behind the scientific process. I think the issue was that he really doubled down and got rather hostile with much of the scientific community. He's basically used this as a bit of a jumping off point to highlight a crisis in science, and he's saying that anyone that disagrees with him is not using common sense and so on. So he's really kind of doubling and trebling down on this idea, and doesn't really seem to be willing to engage with his critics very much.
I guess everybody who's got, a solo idea wants to be Copernicus, but they don't come around all that often, do they?
No, exactly. That's always the problem, right? I mean, they laughed at Galileo, but they also laughed at people that were wrong, right? The fact that you are on your own taking arms against a sea of critics doesn't necessarily mean you're right, unfortunately.
How does the sort of chatter work back and forth with people? You have astronomers working all over the world, sharing ideas, maybe not collaborating on things. I mean, but there's only so much that any one of you can read and engage with. So how does that process work, where you keep up with what other scientists are saying and consider it for yourself, and maybe produce a critique on that work?
Well, I'm happy to say, so science is a beautifully international collaborative affair, and I think particularly astronomy. Because you can only do astronomy observationally from a few sites in the world, it basically forces the world's astronomers to all talk and collaborate. There are a few different channels. The most obvious one being writing papers, right? So any astronomer can write a scientific paper with their theory and then throw it up on this website called the Archive, which is a big list of freely available to anyone in the world. It's a list of all the astronomy papers. And so a lot of the intellectual debate, a lot of the back and forth about ideas happens on the Archive. You often get kind of dueling papers, where some 1 week someone will publish a paper saying X, and then 2 weeks later someone will publish a paper saying no, not X, and it goes backwards and forwards like that. There are also talks that happen. So people often give seminars and colloquia, and then it gets invited afterwards. And then even things as simple as Twitter, right? I mean, astronomers are addicted to social media, just like everyone else in the world, right? So I think there's a big astronomy community on Twitter, and people often argue and hash out ideas on there.
What are the lessons here for how we, as non-scientists who are interested in science, ought to make sense of reporting on exciting headlines such as the ones that came out when Oumuamua was discovered? How do we put all this in context if we're not astronomers ourselves?
I think the context for non-astronomers is to be aware that there are a lot of the time, even in science, there are two sides of the discussion. It gets back to this thing that we were talking about earlier about the role of speculation and science, right? I describe science as this two-stage process where speculation comes up with all these cool, new, exciting ideas, and then that's followed up by arguing and self-critique, and that helps you separate the good ideas from the bad. Unfortunately, the media ecosystem being what it is, and that's just as true on my side of the pond as it is in the USA, the media ecosystem being what it is, it's much more exciting to report about the speculation part of that dynamic than the arguing and hashing it outside of that dynamic. And so a lot of the time when you read things in the press, especially even in scientific publications, right, things like New Scientist here in the UK or science magazines in the US, a lot of the headlines are these very, very kind of cool, interesting, speculative ideas that turn out to be not true. So I think just having a bit of a critical hat on maybe when you read headlines, and yes, a cool, new, exciting idea probably has 10 scientists behind the scenes saying why it's not true, and those 10 scientists might turn out to be wrong, or the headline might turn out to be wrong.
Matthew Bothwell is public astronomer at the University of Cambridge and author of The Invisible Universe, Why There's More to Reality Than Meets the Eye. Matt, thank you so much for spending this time with us.
No, this was fantastic. Thank you so much. I really enjoyed talking about this with you.
You can find our podcast on our website or anywhere you get your podcasts. Again, I'm Chris Boyd. Thanks for listening. Have a great day.